Good morning, all. Today we will see the topic work energy principle. So, before to study this topic, we should know what it means work. Before to start this topic, we should know what it means work. So, work done basic concept is important. So, work is what? If any object is placed on a surface, okay, if F is a applied force, M is a mass of this object. So this object will not do the work until and unless this force is applied. Okay, if there is no motion, then there will be no work done. No work done. Okay, so first basically we will see what are the forces who are responsible for work done. Okay, suppose again same object we are going to take where the slanting force is applied. As we know that if force is slanting, we have to resolve it into two components, F cos theta, F sin theta. Everyone knows this. So this is the first position, this is second position. So object is moving, suppose I am taking a displacement is S. So what are the forces are responsible for work done here? This is F cos theta. Only one force which is responsible for work done, because the object is moving in the horizontal direction, so there will be no motion in the vertical direction. So only one force which is responsible for work done. If I rewrite this formula, and this become F cos theta into displacement, that is S. Okay, this is the work done. Now when the work done is positive, when the work done is negative? When the work done is positive, when the work done is negative. So work done is positive if your applied force is F cos theta is in the direction of your motion. So in this case, this F cos theta is causing the positive work done. It causes the positive work done. And when the work done is negative, so as if a friction force is given, Fr, if the friction is between these two surfaces, if the friction is there in these two surfaces, then Fr is there, which is in the opposite direction of motion. You can see that motion is towards right and Fr is always in the opposite direction of motion. So in this case, the work done is what? Negative. So if I write this one, I can say that positive work done means what? The force and the motion in the same direction. Force and the motion is in the same direction. And negative work done means what? The force is in opposite direction and motion is in the opposite direction. This is force, this is motion. So this is the negative work done. Then what will be the condition that work done will be zero? What are the conditions? What are the conditions where work done is zero? First condition is if displacement is not there, work done is zero. If force is not there, work done is zero. And if the theta is 90 degree, then work done is zero. Means what? Means 90 degree means what? This is the surface and this is, we can say, the horizontal plane, and if it makes the 90 degree with horizontal or the path to the motion, then the work done by this force is zero. Okay, so these are the conditions that work done becomes zero. Now, this is, we can see, the atlas. Okay, atlas hold up the earth, but it does not move. If it does not move, then obviously work done is zero. If I take the meter is moving in the horizontal direction and applied force is suppose perpendicular. So in this case, the work done is 0. He is walking to the horizontal, force is applied to the vertical, then work done in this case by the meter is 0. Now we will see work energy principle. Work energy principle. See here, it's very simple to remember this work energy principle. How to remember one? Work equals to energy. Work is equals to energy. So I'm going to write down work done. Work done equals to change in kinetic energy. So what it means, the change in kinetic energy, if I'm writing this one, final kinetic energy minus initial kinetic energy. That is in short K2 minus KE1. So work done is denoted by 1 to 2. And obviously the unit of work done, as you know that work done unit is force into displacement, Newton meter, or we can say it is in joule. Okay. So this is my formula of work energy principle. I can write this like this. Half m final velocity minus half m v1 square. This is my work energy formula. Remember this is very important formula while solving the problems. Okay. Work energy principle. I'm just showing you where the students are getting confused, where the MGH, that is kinetic energy, is maximum or minimum. So I'm just showing you here. I'm taking this example where the kinetic energy. Okay, so if I drop this ball from this point, this is a building structure and it is getting strike on the surface of the ground. So as this is a free fall, or I drop the ball, so initial velocity is here is 0. Okay, as I know that the kinetic energy KE1 half m v1. v1 means what? Initial velocity v1 square. If u is 0, the kinetic energy at the top point where I am going to drop the ball, that is object, where kinetic energy is 0. Okay, here again some of the students get confused. We are going to study the law of conservation of energy also. In that the students get confused. MGH, potential energy. So remember my dear students, always potential energy is maximum at height. If this is having a height, then potential energy is max at height. Okay, so here in this case, if I want to apply KE is 0. Here the KE is always maximum on the ground. Maximum on ground. It's a max. Okay. Where the height is less, so G, H is 0, that's why the potential energy at ground is always minimum or it's 0. So how to apply the work energy principle when I drop the ball from the top of the building? How to apply the work energy principle? I know that if I want to apply the work energy principle, I need to find out work done first. Okay, work done by whom? When I drop the ball, only one force is acting, that is mg. Only one force is acting. Okay, work done by the mg. If I am considering this is, suppose the height of the building is h. Okay, I'm considering the height of the building is h. So what will be the work done by mg? Okay, the motion is downward and the mg is acting downward only. So both motion and mg, force and displacement in the same direction, that's why it's a plus. Okay, plus. Work done may be negative, may be positive. Mg is a force, isn't it? Which is applied on the ball. into the displacement from this to ground. The displacement is h. Okay. So here my work done is mgh by the gravity force mg. Okay. So this is the work done by the ball. But the question is again remaining. The question is again remaining which one? That is, I got the work done value by mg is mgh, isn't it? I got this one. Work done. But what is work energy principle? So I need to find out, this is the energy. I need to find out change in kinetic energy. Change in kinetic energy. So as I told you that at one position, KE1 equals to what? KE1 is half mv1 square. Here V1 is 0. So the kinetic energy 1 is 0. I'm going to find out kinetic energy 2. Half mv2. At V2, whatever the value is there, if I apply the work energy principle, then work energy principle equals to change in kinetic energy. Change in kinetic energy. So work done I know. I'm putting it mgh. Change in kinetic energy is formula I know, half mv2 square minus half mv1 square. So dear, this is already I got 0. So actually the work done when I drop the ball is half mv2 square mgh. So this is the application of work energy principle when the ball is dropped or it is free. So I hope you understood all of you this work energy principle application. Thank you.